In the previous video, we see 3 different histograms with on the top 200 movie with different bins. So this one is on different interval. The bins are different interval. So this one is 10. So this one we didn't specify any bin. We're just using the default from Python choose for us. So they are the same interval. But you can see not really everyone is 10. So actually you can see they are less than 10 for each one. So the most important thing here, you will see the x-axis that all age is year, but the y-axis is percent per years. The most important thing is the total percent will be the area for each bar. And all the bars add together, they will be 100%. So we want to focus on the y-axis. So the height for the bar, actually we call that the density. Histogram axis, by default, they use a scale that ensures the area of the chart sums to 100%. Like earlier we say, each bar add together will be 100%. So the area for each bar is the percent of the whole. That means the area of each bar means in that interval the total percent. So for example, most of the time your horizontal axis is a number line. For example, we're using the age for our example. That will be years. The bin size don't have to be equal to each other. So in our 3 different examples, the first one, they are different bin size. So since we know the years is the x-axis, so the area will be the total percent. So that's make the vertical axis is a rate. On the other hand, that's a percent per years. So you go back to see the diagram again. You see here is the years, right? So we told you each bar, the area is the percentage. So that's why the area is the length times width. The width is years. So that's make your length is percent per year. So that's why percent per year times year will be the percent for the area. Okay, so that's for all the histogram, no matter your bin is the same size or not. So that's what our question is. Can we calculate the height? For example, for the first diagram, what is the height for 40 to the 60 bin? So be careful, this one actually we should have the 65 actually is the parenthesis. That's mean inclusive. Okay, so then we see here. Can you find the 40 to 60, the height? 40 to 65. So in order to find the height, since we already know the width is 65 minus 40 is 25. So the most important thing, we need to find the area for this one. So this area actually is the percent, right? So we did calculate that. So did you remember here in the bin data, we did add this percent into the bin data and we display here. So that you can see 40 to 65 is 29.5%. Okay, so that will be the total. Okay, so divide by 25, then we can find the height. So that just quickly told you how to do that. But one thing is, of course, let's calculate that. Okay. So the first thing, if you want to find your height for your 40 to 65 bin, okay, so then the same thing, let's see the diagram first. Okay, so then we want to get the percentage. Okay, so the percentage actually you can use in the bin data. Where is the bin is 40. Okay, so then we find that column percent. Okay, so then we're using the first item. Okay, so then we got the percent. Okay, so then, yeah, of course, you need to display your percent. Okay, so that's 29.5. So like earlier, we say the width, right? So width actually is very easy, just the interval 65 minus 40. Even you're not including 65, we're still using 65, the maxima minus the minima. Okay, so then the width, yeah, we need to display. Okay, so the width equal to 25. So then the height, of course, equal to the percent divided by width. So that we get our height. It's about 1.2. So you can see here, if you really see the diagram, they kind of more than 1. So kind of it is not even half of the 1.5. So they are less than 1.2. Okay. Yeah, so that's you can confirm your result. Okay. Yeah, so how to calculate height we showed you earlier. So you can see this one, in the PowerPoint file is different than the Cubic notebook. The reason is here actually we're using the 2022 to minus, but Cubic notebook I already showed you the demo is from 2024. So this answer is the age using the 2022 to minus that release year. So the same thing, the weight, how to calculate. Your 25 is the width, but for that interval is 28%. So divide by 25 years. So that's 1.12 percent per year. So that's your height. And that's the unit for the y-axis. So again, we know how to calculate the height. So the height kind of is the density. So we say the height measures density because you have your percentage per unit. Depends on your x-axis unit. So that will be the percent for that beam divided by the width of that beam. The height measures the percent of data in the beam relative to the amount of the space in the beam. So that's the height measures the cloudiness. So that we call is the density. So the unit for the y-axis or the height is the percent per unit on the x-axis, or we say the horizontal axis. Yeah, so since your area of the bar is a percent in the beam, so that's equal to the height times the width of the beam. So here we can ask you a question. So this one we say how many individuals in the beam. That's area. So one thing is because the area in our example we say by default histogram we're using a percentage. But also right, you can using just the frequency, right? So if the frequency how many count, that will be the how many individual in the beam. So for this one we say how many individuals in the beam. So using the area is not direct value. It's kind of, the area actually is the percentage of the beam. So to get the individual, you're using the area actually just multiply, multiply the area percentage multiplied by the total individual. So we can get the individual for each beam. But how crowded in the beam? Yeah, definitely that's the height. Yeah, so this diagram is the beam. We use different size for the interval. So that's why they can ask you some question. Okay, so you compare the beam for the 10 to 20. Yeah, so remember, lower bound inclusive, but higher bound is exclusive. So that's the parenthesis. So you compare to the 10 to 20, that will be this one, and 20 to 40. So which one has more movie? Yeah, so actually you need to see the area. So we kind of see the area for 20 to 40 is bigger. Okay, so which one more clouded? Okay, so clouded, that means they have the percentage per year is higher, right? So we're using the height. So that is 10 to 20. Yeah, so that's the histogram. So that's kind of to show you on the bar chart style. We call that the histogram. We need to group the numeric data. So in this lecture, we talked about the bar chart at the beginning. They using to show the distribution of the categorical variable. So histogram actually is the distribution for the numerical variable. So for bar chart for the categorical data, so the bar have arbitrary width, we say equal, and the spacing can be in any order you want. You can remove the order. The height or the length of the area of the bar is proportional to the percent of the individuals. So this one will be the same. The height and area both can represent the percentage for the interval. The reason is they have the same width. But histogram represent the distribution for the numerical variable. The horizontal axis always numerical. So you're using the scale, no gap. So the bin can be unequal. So since the bin is unequal, so the area of the bar proportional to the percent of the individual, but not the height. The height actually is the density. Also make sure you understand the difference between the bar chart and the histogram. They look very similar, the shape, but one thing you can see is the distribution for the categorical. They are not numerical number. So if you see the x-axis is numerical number with the interval, that's a histogram. Okay, so let's work on this discussion question together. So what is the height of each bar for this histogram? So this histogram using the my bin is 10, 15, 25, 85. So you see the interval is different. So they're using the income. So that's the income histogram. So actually it's this table. So the first index. So that's why actually it's the income here using the bin. So since you cannot really put that in the Jupyter notebook, so then we can see by this histogram, they will automatically to put those data into different interval, different bins. So that will be the x-axis. So the horizontal axis actually is the millions, right? So then what is the vertical? So the vertical is the y-axis. So we definitely know is something per horizontal axis, so per millions. Right? So one thing is we can know, the first thing, since you're using this column, so that will be the x-axis. So your x-axis unit is millions. So that's why we know the vertical axis unit is what? Is the individual or percentage over your x-axis unit. So we know that will be the percent per million. So here actually in the answer, they do make your percentage for you. So they did make the group. So we have 1 group, 2 groups, 3 groups. So we put that number into the interval. Yeah, you can do that. So then you really get the percentage for each bin. But one thing is because the question itself, they only ask you for the unit. So if you didn't group that, we can know that's a percent per unit per million. But if you really want to get more detailed answer, yeah, that's they got the even the each group. What is the if here is the area for that group, that bin. Okay. So then divide by the width, so we can get the height here for each bin. I hope that helped you to understand. If we go through too fast, make sure you need to pause the video to see the information we provide you. Or get your peer group friend and get together to discuss. Because this one actually is the discussion question. you should try to answer together. So here is the answer for you to refer to. If you have any question, don't forget you also can post in the discussion page in Canvas.